Welcome to 7.2's video. So today we're on page 457 and we're going to learn about angle-angle similarity, side-side-side similarity, and side-angle-side similarity. And you're probably thinking, hey, I already know what side-side-side similarity is and angle-side-angle similarity is, but you actually don't. You know what we talked about is congruence. So, oh, misspelled that. You know side-side-side congruence, angle-side congruence. Now, the pictures will look very similar, uh, but no pun intended, similarity. When it's congruence, remember that all the angles are the same and all the sides are the same. But with similarity, all the angles are the same and all the sides are proportional. So let's to review. Similarity is all angles congruent, all sides similar, which that's sort of cool. It's similarity. It's the same word with a little itchy at the end. So we're gonna jump right into it. So establishing angle-angle similarity. You can conclude that two triangles are similar when they are able to be proof that all corresponding angles are congruent and all of their corresponding sides are proportional. So how I can do this, so I'm going to measure, oh, come on, there. I'm going to measure the angle of DXF. And there we go. And that's 112 degrees. And I can go over here and look, it's the same angle. And then I can change this to being here, this down there, 47 degrees. Oh, look, that's the same. Now I don't need to actually prove that the other angles are the same. I could do this. I want to get rid of this. Oh. I can actually just do math. I don't actually have to do the math, but I will this time. If this angle is 112 and this one is 47, and I go 112 plus 47, this would be a 9, a 5, and a 1. 180 minus 159. I'm going to have a 21 degree angle here. The only other possibility for this angle would have to be 21 because all triangles sum to 180 degrees. So if I only have two angles that are the same, I can assure that the third one will be the same. And I don't need to measure anything. DE, I don't have to figure out the proportion to this DE. I get to know that this is angle-angle similarity, and it will prove that with two angles, the triangles will be the same, will be similar. So, and that's what we have here. With two triangles, I know that angle A would be the same measure as angle D. So this is the given. If I know these two things, then triangles are similar. Now this symbol is similar. If you recall, this symbol is congruent. So similar is only the top little squiggle line. If you write equal or the congruence symbol, that means something totally different. So don't do that. So here we have an example of a problem. Can I prove that these two triangles are similar through the angle-angle similarity? Well, this is 90 and this is 90, so we know E and A are the same. Looking at the picture, is there anything about the picture that says other angles would be the same? Oh, you're right. Angle ACB and angle DCE are congruent because they're vertical angles. So I've met angle-angle similarity. Whatever this measure is, 90 plus this measure would equal an unknown number. And the exact same measure of 90 plus that would equal the same number. So I don't need angle, angle, angle. Just proof 2. Each triangle shown is an isosceles triangle. Determine whether you have enough information to show that the two triangles are similar. So isosceles triangles have base angles being the same. Now, there's nothing about this triangle sidewise that says that the same sides. So I don't know that this angle is the same as this angle. And if I copy an angle with my fancy copying, I put it over here, I can see that they're not the same. So just because this angle equals this angle and this angle equals this angle doesn't translate to it being similar. Now this picture has something new added to it. It says that T and W are the same. And we would know that this angle equals this angle, put 2 there, and this angle has to equal this angle because they're both isosceles triangles. So do I have enough information here? Well, if T is, let's say, 90 degrees, then these two have to be the same of the remaining 180 degrees, so 90 degrees, 90 over 2. So if this is 90 and W is 90, then I'd still have 90 over 2, and they'd both be 45. If it was 100 degrees, then I'd have 80 over 2 and 80 over 2. So B does have it. And if I look at and make a triangle, I wonder if this one's the same angle. No, not the same. So I'll make another angle just to show that these angles are, in fact, congruent. Look at that. Okay, so A is a no. They're not. Not similar. Triangles. We don't know anything about. We don't know anything to relate triangle A to B. And then for the second one, why is this? The second one, B, is a yes. Can conclude that the base angles have to add up some because angle T and W are congruent. So get that written down, and then I'll be on the next slide. Okay, we got another theorem. We got the side similarity theorem. This one, just like side congruence theorem, but the side lengths have to be proportional. So if AB is twice the length of DE and CB is twice the length of EF and AC is twice the length of DF, they're similar. If this AC is different length or similar from this as the other ones, then they're not similar. They all have to be the exact same scale factor. So here's how I would go about proving that. So I have to make some proportions. This is just going to be some division. The biggest side on this one is 36. So 36 divided by the biggest side here, 24. Then I'll do the smallest side on this one, which is 24, over the small side here is 16. And that leaves me with the only other side of 33 over 22. I already did 16, I already did that. Now, if you see that they're the same, great. If not, we'll just put them in the calculator. 36 divided by 24 is 1.5, or 3 over 2. 24 divided by 16 is 1.5, or 3 over 2. And this one, if I divide by 11, I can see it pretty easily, 3 over 2. So I had to do, oh, what's happening there? Oh, I had to do this similarity statement 3 times to show that each side is similar, because it is the side, side, side similarity. And next we have the side angle side similarity. So here's if I have two sides that are the same, so proportionality between AB and DF, and then proportionality between AC and DF. So that's these two, and then I know that the included angle between them of A and D are the same, then it will be this. So it's the same included angle as side angle side congruence, but it's similar triangles, so therefore all the sides have to be just proportional. So the U-do is going to be on page 469 through 470, numbers 3 through 6. So when you get those done, come do your check-in.